Dear students, today we are going to start with a new topic, a new chapter, that is alcohols, phenols and ethers. So before starting with the chapter, subscribe the channel, like it and share it with your friends. Let's begin. What we are going to learn at the end of the session, at the end of the chapter you can say, that is, we are going to learn regarding alcohols, phenols and ethers. Related to them, first we are going to see the introduction, nomenclature, classification, preparation methods, physical properties, chemical properties and uses. So in this way, we are going to see and understand each and every topic in relation to alcohols, phenols and ethers. So let's continue. Dear students, now we are going to understand what are alcohols. Here you can see a carbon atom. We are knowing carbon atom is having 4 valencies. That means it is tetravalent, as it can be seen here. In this carbon atom, when one of the hydrogen is removed and replaced by OH, we say the compound is alcohols. It can also be said as whose molecules contain hydroxyl group, that is OH, attached to a saturated carbon atom, as we can see here. Such compounds are said to be alcohols. Hydroxyl group can also be present in aromatic compounds.
Alcohols are organic compounds containing the hydroxyl functional group. They are formed by replacing the hydrogen atom of a hydrocarbon with a OH group.
Let's talk about aromatic hydroxy compounds. They can be seen as phenols and aromatic alcohols. What are phenols? Hydroxyl group directly attached to the carbon atom of a benzene ring is said to be phenol. Example, as it can be seen here, this is a benzene ring. OH group is attached directly to the benzene ring. This is phenol. Let's talk about aromatic alcohols. Hydroxyl group is present in the side chain of aromatic ring. As it can be seen here, this is the benzene ring. To this benzene ring, a side chain is attached. To this side chain, OH group is attached. Such alcohols are said to be aromatic alcohols. Let's talk about phenols. What are phenols? This carries a benzene ring wherein OH group is directly attached to the benzene ring. In this compound, we see the blue color atoms are carbon atoms, grey colored atoms are hydrogen, and red colored is oxygen. For better understanding, we can see here it is a benzene ring. To this benzene ring, one bond is seen wherein OH group is directly attached to the benzene ring. This is phenol. Phenols contain an OH group directly connected to a carbon atom which is sp2 hybridized in a benzene ring. Let's talk about ethers. In this figure, we find there is a red colored atom, which is oxygen atom, whereas the grey colored atoms are carbon atoms and white are the hydrogen atoms. Here we find this is the divalent oxygen atom to which alkyl groups are attached. As we can see here, compounds which contain an oxygen atom bonded to two alkyl groups, which is indicated by R, or two aryl groups indicated as AR, or one alkyl and aryl group is said to be ether. Ethers are organic of alcohols. We can see here R bonded to oxygen, which is bonded to R, that is alkyl group. We find here this is oxygen atom, which is divalent. One valency of this oxygen is satisfied by alkyl group and another by other alkyl group. Here we find on one side the valency of oxygen atom is satisfied by alkyl group and on another side it is satisfied by aryl group. Whereas in this third case we find both are alkyl groups attached to the divalent oxygen atom, but both the aryl groups, it may be different. One may be substituted, possibly. Let's talk about classification of alcohols. Alcohols are classified as monohydric alcohols which contain one OH group, dihydric alcohols which contain two OH groups, trihydric alcohols which contain three OH groups, and fourth, that is polyhydric alcohols which contain more than 3 OH groups.
Alcohols are classified as monohydric, dihydric and trihydric depending on the number of hydroxyl groups. They are further classified as primary, secondary and tertiary according to the hydroxyl group attached to primary, secondary and tertiary carbon atoms respectively.
Let's understand the classification of alcohols further. Here we find, as we have already seen, monohydric alcohol. The example is C2H5OH. Here only one OH group is present in the compound. The name of the compound is ethyl alcohol or ethanol. Let's talk about dihydric alcohol. Dihydric alcohols contain two OH groups. As it can be seen here, CH2OH bonded to CH2OH. Example is ethylene glycol or ethane 1,2-diol. Let's talk about trihydric alcohols. Example is CH2OH bonded to CHOH bonded to CH2OH. This is trihydric alcohol. Example is glycerol or propane 1,2,3-triol. Polyhydric CH2OH, CHOH 4 times, CH2OH. Name of the compound is sorbitol. Example is hexahydric alcohol. Now we are going to understand the classification of monohydric alcohols. Monohydric alcohols are classified as alcohols containing COH bond where carbon atom is sp3 hybridized. And the another way of classification, or the second part of the classification, it is divided into second part, that is alcohols containing COH bond where carbon atom is sp2 hybridized. As we can see here, in this monohydric alcohol, we find OH group is attached to a sp3 hybridized carbon atom of alkyl group. Whereas in the second case, we find OH group is attached to a sp2 hybridized carbon atom of alkyl group. Let's talk about alcohols containing sp3 hybridized carbon atom bonded to OH group. Example is, first we are going to see primary alcohols. As it can be seen here, the example given here is C2H5OH, that is ethanol or ethyl alcohol. As we can see here, the OH group is attached to primary carbon atom, so that's why it is primary alcohols. Let's talk about secondary alcohol. Here, OH group is attached to the carbon atom, which is secondary carbon. So here, since OH group is attached to secondary carbon, we find the alcohol obtained here is secondary alcohol. The name of the compound is Prepn. The third example is tertiary alcohol. Here we find the OH group is attached to the carbon atom, which is tertiary. So OH group is attached to tertiary carbon atom. That's why it is said to be tertiary alcohol. Name of the compound is 2-methyl-propan-2-ol. Let's understand the monohydric alcohols containing sp3 hybridized carbon atom bonded to OH group. We are going to deal with allylic alcohols. So let's understand what are allylic alcohols. Here, OH group is attached to sp3 hybridized carbon atom next to carbon-carbon double bond, which is said to be allylic carbon. In this case, we are going to understand primary alcohols, primary allylic alcohols. As we can see here, OH group is attached to that carbon atom which is attached to the carbon atom which is doubly bonded. Such alcohols are said to be allylic alcohols. And since OH group is attached to CH2 group, where carbon atom is sp3 hybridized and it is primary carbon. Example, prop 2 in 1-ol. Let's see the example of secondary alcohol. As it can be seen here, the example is CH2 double bond CH, single bond CH bonded to CH3 and bonded to OH group. Here OH group is attached to sp3 hybridized carbon atom, and this carbon atom is secondary carbon. That's why it is said to be secondary allylic alcohols. Name of the compound is but3-in-2-ol. Now we are going to understand tertiary allylic alcohols. The example is CH2 double bond CH, single bond COH, and this carbon atom is bonded to CH3 and on this side also CH3. Here we find the OH group is attached to tertiary carbon atom, which in turn is attached to the doubly bonded carbon atom. Such alcohols are said to be allylic alcohols. The OH group which is attached to the carbon atom is sp3 hybridized. Name of this compound is 2-methyl but3-in-2-ol. Let's understand monohydric alcohols, that means alcohols containing sp3 hybridized carbon atom to which OH group is directly attached. Now we are going to see benzylic alcohol. What do you mean by this? Here OH group is attached to sp3 hybridized carbon atom next to aromatic ring. Let's talk about primary benzylic alcohols. In this case, we find benzene ring is present, and here the OH group is attached to the carbon atom which is sp3 hybridized, which is attached to the benzene, or you can say benzene ring. Name of the compound is phenyl methanol. Now let's understand secondary alcohols, secondary benzylic alcohols. As you can see here, OH group is attached to the carbon atom which is sp3 hybridized, in turn which is attached to the benzene ring. Here we find this carbon atom is secondary carbon atom. So the molecule here is secondary benzylic alcohol. Name of the compound is 1-phenyl ethanol. Now we are going to understand tertiary alcohols, tertiary benzylic alcohols. As we can see in the example, OH group is attached to tertiary carbon atom, which in turn is attached to the benzene ring. This carbon atom is tertiary carbon atom and also it is attached to 2-methyl groups. Example, the name of the compound here is 2-phenyl propan-2-ol. Now we are going to deal with the monohydric alcohols containing carbon atom which is sp2 hybridized and bonded to OH group. So OH group is attached to sp2 hybridized carbon atom of the alkyl group. Now let's understand vinylic alcohols. What are vinylic alcohols? Here OH group is attached to sp2 hybridized carbon atom, which is the part of carbon-carbon double bond. As we can see here, OH group is attached to the carbon atom, which is sp2 hybridized, and it is doubly bonded to another carbon atom. Such alcohols are said to be vinylic alcohols. Name of the alcohol is vinyl alcohol. Now we are going to see classification of phenols. Phenols are classified as monohydric phenols, which contain one OH group, dihydric phenols, which contain two OH groups, trihydric phenols, which contain three OH groups. Let's understand the classification of phenols. Phenols are classified as monohydric phenols, dihydric phenols, and trihydric phenols. Example for monohydric phenols. Mono here indicates one OH group. So here phenols containing one OH group are nothing but monohydric phenols. Example is phenol. Dihydric phenol contains two OH groups, di indicating two. Name of the compound is catechol. It is also named as benzene 1,2-diol. Let's talk about trihydric phenols. These compounds contain three OH groups. Name of the compound is fluoroglucinol, and it is also named as benzene 1,3,5-triol. Now we are going to see the classification of ethers. Ethers are classified into two types. First is simple or symmetrical ethers, and second, mixed or unsymmetrical ethers. What are simple or symmetrical ethers? Here, the alkyl or aryl groups attached to the divalent oxygen atom are same. Example is diethyl ether. As we can see here, oxygen atom, which is divalent, is bonded to the same type of alkyl group on both the sides. Here we find it is ethyl group on both the sides of oxygen atom. Let's see what do you mean by mixed or unsymmetrical ether. Here the alkyl or aryl groups attached to the divalent oxygen atom are different. As we can see here in the example, the divalent oxygen atom on either side is bonded to two different alkyl groups. Here one is ethyl group and another is methyl group. Let's further understand the classification of ethers. Simple or symmetrical ethers, or mixed or unsymmetrical ethers. Example, CH3O CH3. Since both the groups attached here are similar, they are said to be simple ethers. These groups attached are methyl groups. So the name of the compound is dimethyl ether. Another example we can see here. Since the two groups attached to the divalent oxygen atom are ethyl groups, the name of the compound is diethyl ether. Now we are going to see The examples for mixed or unsymmetrical ethers. Here we find one group attached to the divalent oxygen atom is methyl group and another is N-butyl group. So the name of the compound is N-butyl methyl ether. Let's see another example. Here one group is methyl group and another group is N-propyl group, CH2, CH2, CH3. Name of the compound is methyl N-propyl ether.